All right, I guess we'll see how many shades of red I can turn. It's really intimidating because all of the slides coming up yesterday, today have been awesome. The speakers have been awesome. And then all of the slide decks have been really polished. And from me, you're going to get black slides with white text and some screenshots, just to warn you. But hopefully the technical content will make up for it. And conveniently, I am not going to be talking about web page test at all. But I will be here for the rest of the day, so if you have any questions, I'm happy to talk about web page test all day. But I'm going to be talking about prioritization. And so it was awesome to have Harry really get excited about the head and reordering the head and moving things in the page, because that's pretty much web performance, for me at least, from what I've seen over the last 20 years, and it hasn't really changed. It's two things: get rid of crap, reorder crap. And so it's, once you get rid of as much as you can on the page, it comes down to, okay, how can I juggle all the stuff I still have to deliver to try and get it to deliver quickly for the user? And so that's pretty much what prioritization comes down into play. And it's changed a lot as we moved into HTTP2. So really quickly, just going to kind of do a really broad deep dive into prioritization as it stands. Browsers. There's really not a whole lot of complicated logic to what a browser does when it's loading things. And so the thing you need to know for the browsers, there's the preload scanner and sorts of all other stuff, but the main parser, the thing that goes through your HTML one line at a time or one character at a time, style sheets block render, no matter where they are, usually style sheets in the head. And non-async script tags, so blocking script tags, usually in the head, block the parser. And so the parser can't see anything in your document until after it gets past that script tag. And it stops there until any style sheets before it have loaded, so the style sheets become blocking as soon as you have a script tag, and it blocks until that script tag has loaded. And then it can finally go, oh, okay, I can execute this script and go on to the next thing. And so if you sort of mentally think of yourself as the parser when you're looking at your HTML, you can kind of go through the head, as Harry was saying, and you can kind of go and look, okay, it's going to freeze here until it loads this third-party tag and my CSS before it, and then it can go on, and it doesn't know anything about your DOM, which is why the head matters so much, until it's actually made it into the document. And so there are a couple of things. So I talked a little bit about the preload scanner. It's sort of when the main parser stops and gets paused, there's another scanner in all of the browsers these days that tears through your HTML and looks for anything that might be an URL that it might need, an image, a script, anything. And it goes, you know what, I'm going to need this eventually. Let's load everything we can as soon as we can so we have it ready. But these are the things that the browser knows about. There are certain things that aren't in your HTML, tend to refer to them as late discovered resources. Harry had issues with certain cloud font providers. I have issues with all web fonts. They're evil. I understand designers love them. They make sites look pretty. I'm sure there's conversion uplift, but they're like the most evil thing on the web. From performance at least, because by the time the browser knows it needs a font, it's trying to draw the text. And so the browser's going, hey, okay, I've made it through all of my script tags, I've made it through all of my style sheets, I'm going to draw the headline and the text that you asked for. Oh crap, I don't have the font. Let me go think about fetching that now before I can draw the text. Same for background images and the style sheets. They tend to be less of a problem than fonts. Any script injected content. So if you've got like Google Tag Manager or any tag managers in your head are sort of the big culprit for these. Anything that they inject into the document, the browser has no idea what it's going to do until it runs the code. So the preload scanner can't see them. And any imports from CSS and ES6 modules and things like that that aren't Webpack bundled, the browser can't see those, so the preload scanner can't see those. So I'm going to take like the most simple 1979 web page, like before the web existed. There are no third parties. It's all served from one origin, one HTML file, one style sheet, 4 scripts. 2 of them are blocking in the head, 2 of them are down at the bottom of the document. one web font, because I want to show you how evil they are, and 13 images. Some of them are above the fold, 5 of them are above the fold, the rest of them are sort of below the fold. And it's kind of your typical news content type page, if you would. And so for scripts in particular, when we're talking about resource loading at least, there is, I'm going to be very opinionated, but there is an optimal way to load your scripts. And that is to load one script at a time in the order the parser is going to hit them, 100% of the bandwidth dedicated to each one of those scripts. Because that way, when you've downloaded the first script, it can start executing while you're downloading the second script. And you can sort of pipeline the downloads and the executions. If you download both of the scripts at the same time, sharing bandwidth, then by the time the parser gets to them, it needs to execute them serially, and you end up with a later time. So for scripts, optimal would be 100% of the bandwidth in the order in the document, one after the other. So for our page that we were talking about, it has an overall optimal loading sequence as well if you want to get as much visible content to the user as quickly as possible. So your start render as soon as possible, your above the fold as quickly as possible. I'll warn you right now, the images are going to be very contentious. I am a huge fan of progressive JPEGs. Tammy, wherever you are, broke my heart with the research study. We still debate on how accurate it is, but that users may or may not like progressive images. It may make them work harder. So depending on how you feel about progressive images, downloading images concurrently or one at a time, I tend to feel, so with progressive JPEGs in particular, by the time you get 50% of the way into the bytes, visually the image is almost indistinguishable from when it's 100%. And so you can get visually complete on the page about twice as quickly if you download concurrently than if you download one image at a time completely until going on to the next one. And so on our sample page, if we load the HTML first, kind of have to, the CSS is before the script tags. Remember, the CSS is going to block the script execution, so we want to go ahead and load that as quickly as possible. The script tags 100% of the bandwidth, so we're going from time left to right, and then vertically it's the pipe, if you would. The internet's nothing but tubes, right? And so this is what we're shoving down the tube to the users. The script one after the other, so that the browser can execute them one after the other. At that point, we've made it out of the head. We're into the document. We can render something. We don't have our web font yet, so we can't actually render any text, but we can render sort of the shell of the page, the color of the divs, and that kind of thing. The browser, panics, fetches the web font. We can now draw all of the text. And then, so keep things simple because I suck at math. We're going to assume each one of the sort of blocks of unit of time is 1 second. So you're downloading the script for 1 second, the HTML for 1 second. So around 5 seconds, you've got all of your content and the text displayed. No images yet, they're still all blank. We're downloading the images concurrently because we all love progressive JPEGs, right? So about halfway, we're at about 7 seconds. The page is visually indistinguishable for what it's going to be complete. But even if we wanted to wait until 100% of the image bytes come in, at 10 seconds, we've got all of the above the fold content rendered, visible to the user, and then we can run the async scripts or the scripts at the bottom of the page. We need to run the marketing, remarketing tags, the analytics, sort of all of the things the business is going to yell at you if you move too far out of the way. And then we're going to go ahead and load all of the images that are down below the viewport. You can lazy load them if you want. Also not a huge fan of lazy loading, just because it ends up being one of those races where, okay, so when you lazy load, I'm more of a fan of load all of your visible content and then load your images lazily after that, but don't wait until the user starts scrolling because you end up in a race condition with, can you start fetching and complete fetching the image before the user gets to it? But like I said, I'll be opinionated. The worst case that we can do for this is to download everything all at the same time, sharing the connection. And so what happens in that case, we download the HTML, and then we start downloading all of the content. We don't know about the font yet because it's late discovered. And so we've got the scripts, the style sheets, the async scripts, the below the fold images and the above the fold images, all downloading at the same time, a completely blank screen until you get to 19 seconds, at which point everything displays except for the text because of evil web fonts. And so the web font loads, and at 20 seconds, we finally have something for the user to consume. And so the difference between those two loading strategies, we're loading exactly the same content, we're just changing how we order it, how we load it, is from about 7 seconds for everything to be complete until 20 seconds. So more than twice as fast to load the content just by changing the order on how we're loading it. Pre-HTTP 2 and the HTTP 1 days, the browser was largely the one responsible for making these decisions. It would open up 6 connections per origin, and the browser maintains a list in memory of the things that it needs in the order that it needs them. And so, at least in Chrome's case, it would basically maintain this linear list. As a connection became available for an origin that it needed, it would pick the first item off the list and fetch it. And then as things reprioritize, like as the font comes in and it knows it needs the font, it'll put it at the front of the in-memory list, and whenever a new connection became available, it'll go ahead and fetch it next in front of all of the images and everything else. One of the biggest changes for HTTP 2 was the browser no longer controls prioritization. The browser can still maintain its list, and it can decide how important things are, but it tells the server, here's all of the things I need. I'd really like it if you could send it to me sort of in this strategy or in this order, but I'm trusting you're gonna do the right thing and send it to me. And then, like the web font, or like in the case of Chrome, visible images in the viewport get a higher priority than below viewport images. It doesn't know that until it's done your layout, and so all images start at a low priority. Layout happens, and then Chrome sends a priority frame that says, oh, those 5 images I sent you before, they're high priority now, send them to me now. The HTTP 2 model, extremely flexible. Too much so, perhaps, but as they were designing the spec, they created a generic tree with arbitrary weights that the browsers can send, and they can build whatever hierarchy they want. And you can sort of see where we're going with this. All of the browsers did something completely different. And so nothing, this is part of the fun of the web, right? Nothing works the same on any browser. Chrome creates a linear list, matching what it would normally have in memory. This is the order I'd like things in. It works great for scripts, style sheets, that kind of thing, right? We discussed scripts work best in order, 100% of the bandwidth. Images, not great. So it is serializing the images one after another, but it's still generally in the, I'd say, the good camp as far as performance goes, especially if you don't like progressive images, like Tammy. Firefox went all in. I mean, they loved the tree. The tree was awesome. We're gonna build this awesome structure for it, and so they created 5 different groups that are placeholders that organize the different resources into a weighted tree. And so they can put lazy resources all the way over here that only get downloaded if there's nothing that's in one of the higher priority groups. And then they have groups that are sort of staged so that all of the resources in one group will download before any resources in the next group. And then between 2 groups, like leaders and unblocked, you can have the JS over there and images over here, and the images will have twice the weight of the JS as a group. So it has interesting sequencing. They give higher weight to more important resources, but one of the biggest differences with Chrome is that within any group, everything downloads all at the same time. And so in Firefox, we're in a situation where all of your scripts are all downloading concurrently all at the same time. Not great. But images, the Firefox model is better for me anyway, because the progressive images are all downloading at the same time. Safari looks a lot like it was frozen in time at the point Chrome forked Blink. And so the speedy model was a lot simpler than HTTP 2. And what it did was it had weights from 1 to 5. And it basically, depending on what the weight was the order that things got delivered in. And so Safari basically just took those 5 weights, or those 5 priorities, map them to weights. But everything downloads all at the same time. It's just images get less priority than scripts. So scripts will get like 3 times the bandwidth of images, but all of the scripts, all of the images all download at the same time. It's just scripts and CSS get a little more of the bandwidth. So it still ends up being in a situation where you get most of your critical resources sooner than your low priority resources. And it's a much simpler model. Edge, before Chrome, doesn't support prioritization at all. And so the default mode for HTTP2, if prioritization is not supported, is everything downloads all at the same time, all with the same weight, which if you remember our earlier models is absolutely the worst thing you could do for the web. And so very, very excited that they're moving to Chromium. Hopefully that won't be a problem anymore. It's sort of the IE6 of the web resource loading. This was a really simple model. Remember, we had no third parties. I don't know if any of you have ever seen a site that has no third parties. I mean, even google.com has a bunch of different origins it fetches from, so we're in a much more complicated world. And prioritization across connections, when you're talking about first party, third party, even static resources, for those of you who don't know, this is Mad Max Thunderdome, and that's basically what it comes down to, is the browsers throw everything on the wire and let the network sort it out. And so now the servers have no control over it, the browser has no control over it, and it comes down to whatever the network's going to prioritize among the different connections. And we can do this a lot to ourselves. So there is third parties, domain sharding, which we did a lot for HTTP 1. If you've got any static domains, odds are you're doing this to yourself. There is, I think I have a slide on it later. HTTP 2, there is a way to coalesce the connections, so all of those go over a single connection, but you're still paying the cost of having to do a DNS lookup in that case. So if you were ever doing domain sharding, now is a good time to sort of back off of that. Even if you're doing HTTP 1 in effort to migrate to HTTP 2, there's not a whole lot of reasons to be doing it anymore. And this is what it looks like in a waterfall. So this is a connection view waterfall rather than sort of a normal waterfall, and you can see this is like, oh, this is CNN, and so it's obviously way truncated because I think CNN has something like 200 third parties or something ridiculous. But you can see yellow are scripts, red are the fonts. So the fonts, even though they're super high priority, they're downloading concurrently with all sorts of other scripts. The web page test waterfalls were updated so that the dark parts of the waterfall are when data is actually downloading, so you don't have necessarily a long dark bar for when it's time to first byte to complete. You can see each chunk of data as it arrives, and you can see sort of the network sorting out across the different connections, but you've got high priority stuff, low priority stuff, images, fonts, scripts, all downloading concurrently, even though both the client and the server support prioritization, because HTTP2 prioritization only works on a single connection. The server can only prioritize resources that it knows about, and so the separate connections aren't prioritized against each other. Ryan in the house. And so even if you're using like a image optimizing CDN, or the publishing platform you're using is using an image optimizing CDN, that ends up on a separate origin from your main origin, your main resources, and now you've got your images competing with your JavaScript because they're coming from a different origin. And so I'm not saying don't use image optimizing CDNs, but if you can find a way to like front them with your CDN, the same CDN that serves your origin, you'd be in much better shape because then you can prioritize your images against your scripts. Yep, talked about connection coalescing. So connection coalescing is a way for HTTP2, if you have static domains, different domain names, if you serve the same certificate to both of them, so the certificate name includes all of your domain names, and they resolve to the same IP addresses, then the browsers will request over the same connection. And so you can serve multiple domains over a single connection, but it doesn't work if you're using like an image CDN, for example, that's a different origin from your main CDN. Or like one of the top retailers in the US has a multi-CDN strategy where they use Akamai, Cloudflare, Fastly. They basically use all of the CDNs, and they decide at runtime which one's cheaper or more appropriate for them to serve, or they'll serve some assets from one CDN from another. And when you do that, all of a sudden you can't coalesce your connections anymore because you're actually serving from different CDNs. And so you're shooting prioritization in the foot. And so one of the things that when I first joined Cloudflare, I was like really excited. And it's like, okay, you know, fonts. I hate fonts. If it's not clear yet, I hate fonts. But Google Web Fonts in particular annoy me. And the main reason for that is when you use Google Web Fonts, first you include a CSS file, which is the top arrow, from Google Web Fonts origin in your head. So it's a third-party domain in your head, so it needs to do the DNS lookup, socket connect, TLS negotiation, fetch the CSS before it can execute whatever else JavaScript you have in your head. And then when it goes to fetch the actual font, it does it from a completely different origin. And so you'd need to do another DNS lookup, socket connect, TLS connection, and fetch for the font. And so not only does the browser have to do sort of the last-minute panic of, oh crap, I don't know how to draw your text. It's, oh crap, I don't know how to draw your text, and I don't know where the hell to get your font from. So I need to go figure all that out first. And so when I started out Cloudflare, one of the first things I wanted to do was fix this problem and make Google Fonts run from your origin. So transparently proxy Google Fonts, if you would, from the CDN behind. And so I did it. And the waterfall went like crap. I was like, holy shit, what the hell happened? All I wanted to do was move the fonts onto the origin. All of a sudden, my start render time ended up at the end of my waterfall at like 9.5 seconds. And so it ended up, the prioritization was actually broken on the Cloudflare side of things. And so even though I was proxying the fonts from the origin, the images, the CSS, and everything else were all coming from the same origin, but they weren't getting prioritized. The prioritization ended up randomly, and so on any given page load, you would get resources in completely different orders, and your start render time would go all over the place. It would be really early if you happened to get all of the head resources early, but it could also be really late if it decided to download all of the content images before it downloaded the CSS. And the browser wasn't doing anything different. This was a problem on the origins that I'll dive into why in a second. But once we got it fixed, yay, fast render, and in this case, we were actually preloading the fonts as well. So by the time we went to render, we had all of the fonts ready, and so we could draw all of the content really quickly. I didn't feel like I had been a complete failure at that point, and I could still have a job. So we were loading Google Web Fonts as if they were origin served, so all was good. And then Zach, I don't think Zach's here, but Zach is like the god of fonts. So when he started doing this, it really freaked me out. I was like, okay, I got Cloudflare fixed. All is good with the world. No one has to know we were broken. And then Zach moved his fonts from his origin to a separate origin to speed them up. And I was like, you know what? That sounds very familiar to the brokenness that I was just fixing. And it turns out his origin was also broken, and it wasn't on Cloudflare. And at that point, it was like, oh crap, how much of the web is broken? And so I worked with Andy on a prioritization test for the web to see how well HTTP2 prioritization is working for any given origin. And so there's this page on webpagetest.org where you can just give it a query param of any image that is hosted on your origin somewhere. Roughly around 100K image would be best, just to get the timing right so you can see the prioritization working. Oh, I should mention I see lots of cameras. Feel free to take pictures, but on the first and last slide, all of the slides are up on SlideShare, so all of the URLs and all of the content and stuff, you don't have to like memorize now. So you pass it the image URL of the server that you want to test as a query parameter. Just make sure you URL encode it as a test into web page test. So it's very meta. Web page test is testing a web page test URL with your image on it. The most important thing is use a 3G fast connection. Chrome changed its logic. So on really slow connections, it decided that HTTP2 was too broken, and it's going to do HTTP1 style prioritization on the browser side. So anything slower than 3G fast, and you're not testing HTTP2 anymore. And so what the test actually does and what it looks like is it loads that one image a whole bunch of times. First, it warms up the connection to the origin to just try and get rid of some of the TCP slow start issues. And then it will request 30 copies of that image as below the fold copies of the image, so really low priority. Followed by, once the first 2 images have been delivered, to sort of make sure the pipe is warmed up and stuff is flowing through the connection, it will serve 2 in-viewport high-priority images. And what you want to see is you want to see those 2 images down at the end of the waterfall, the high-priority images, interrupt all of the other images so that you know the server is reprioritizing content correctly. And so the high-priority stuff jumped in front of the low-priority stuff. And you can see the sort of gaps in the data download of the existing image flow. And so in an optimal world, you've got the standalone warm-up one image download by itself. In an optimal world, even when your pipe is full and you request a high-priority resource, you would still get it back just as quickly. In reality, it's going to be a little bit slower, but you're still going to get much faster than if it wasn't prioritized. What it actually looks like and when things go wrong, those last 2 high-priority resources will end up being all the way at the end of your waterfall or somewhere lower. And what you really need to think about when it's doing this is when this happens, you're in that really screwed up waterfall state that I had with my web fonts, or you're in the case where a late discovered resource like a web font is going to be blocked on all of your low priority resources, all of your images that are loading. And so you'll end up with situations where you'll have like 20-second blank pages or 20 or 30 seconds with no text when prioritization isn't working. And so these are all examples of what we see in the wild. So this one, I'm not entirely sure, but it looked like they were just round-robining across all of the resources independent of the prioritization, and you can see little chunks of data coming across no matter what the priority, but the high-priority images still end up way out here. I honestly have no idea what was going on with this one. It looks like it took maybe the first 6 round-robin those and went, you know what? I can't do any more. I'm going to get these out of the way. And then it just gave up and loaded one at a time. You see all sorts of weird shit when you actually look at the real internet. And so this one looks like they downloaded half of each image, went on to the next image, and then went all the way back to the beginning and downloaded half of each image again. But still, you have the issue with where your high-priority images didn't actually download when you wanted them to. And yeah, at this point, I just stopped trying to guess what the servers were doing. This one, it looked like it serialized the first 10 or so images, and then it went into a download half of each at a time kind of a model. And so we stood up, is HTTP2 fast yet? Totally riffed off of Ilya's, is TLS fast yet? And we ran that test against basically every CDN and cloud hosting provider we could think of. And no, only 9 of the CDNs actually prioritized correctly, or 9 of the origins we tested. The big ones, pretty much Akamai, Cloudflare, and Fastly. If you're using any of those 3, prioritization, you can relax, prioritization's working, all is good with the world. This list is a little scary. So there are a lot of big CDNs, image CDNs, Amazon CloudFront. I hear a lot of groans and freaking out in the audience. Yes, that is the right reaction. And every one of the cloud providers is broken. So yay, let's all move to the cloud. If you are a customer of one of these, my main ask, my beg of you, is talk to your account rep and make it their problem. Because we've talked, it's been broken for a year, by the way. We stood that site up about a year ago, and there hasn't been one company that has moved lists yet in that year of shame. But we have had 2 or 3 really large AWS customers, for example, working with their account reps to the point where it's on their radar, but that's as far as they'll commit, which may just be a quit talking to us, we understand, but we're not actually going to fix it. So I think there could be more pressure applied, for example. Or you could just front it with one of the CDNs that does work, but it would suck to have to pay twice if you're already using a cloud provider or a CDN. When you're testing for this locally, and my apologies, DevTools is awesome. The one thing that's not awesome about DevTools is the traffic shaping. I was really excited to see Harry's slide. Harry was using network link conditioner. A lot of people have Macs. It's free. Xcode includes a thing called network link conditioner. It does packet level traffic shaping. So the HTTP issues that we were talking about are all really low level protocol problems that only work and show up if you're doing your connection emulation at the packet level. Chrome's DevTools throttling is really good for giving you an idea of, I have a really heavy page, it's going to kind of feel like this, but it's really bad at protocol level stuff because the traffic shaping is done within the application and it's done between internal Chrome guts, but between the renderer and the browser processes of Chrome as it's moving data around. So it actually reads data off of the wire as quickly as the wire speed. And beyond prioritization, that's also completely broken for HTTP 2 push, which is the other big one. Push ends up being completely wrong if you're using Chrome's DevTools throttling. So on Macs, network link conditioner, if you happen to be Windows-based, there's Windows Shaper. I forget, WinShaper, I think is what I called it. I built a network link conditioner clone basically for Windows. And Web Page Test does packet level shaping. It uses NetM on Linux for most of the traffic shaping. And so just to give you an idea of what it looks like in DevTools, this is the same prioritization test for a good origin where it is running the prioritization correctly. Because of how Chrome's traffic shaping works, since it's after the data has actually arrived that it's doing the throttling, you end up, it looks like prioritization's completely broken. And so it's not giving you sort of an accurate waterfall for what's really going on. The other thing to watch out for, and I think I have it on the next slide, but right around the time that this happened, I changed Web Page Test's waterfall to show you the actual chunks of data arriving because of this. So you can see how it's sending you data as far as the prioritization, is it round robin or whatever. And you can see it's fairly common. There's a really thin dark line right at the beginning where the server sends the headers back, and then it actually prioritizes the data. So it's not unusual for the headers to arrive immediately. And historically, what that would look like is a bar like this in Chrome's DevTools, where you have a really dark line for the entire time, but you can't see, you sort of see, okay, they all sort of seem to be downloading at the same time, but it really helps when you can see the actual data flow and when the data's arriving. Yeah, and so like I was saying, it's not unusual to see the HTTP headers themselves delivered early because they aren't prioritized. On your monitoring systems, if you are using synthetic monitoring, RUM is great. You don't have to traffic shape RUM. RUM is what the actual users are doing. But if you are doing synthetic testing, things to just sort of watch out for is if they're using DevTools or Lighthouse without custom traffic shaper outside of Lighthouse, Puppeteer, or if it's using a proxy. Pretty much any of those will not expose your network layer problems. And this is where we dive a little lower into the networking stack. Hopefully, you don't necessarily need to know this, but I think it helps with the mental model. I don't know if anyone catches the Snowden reference. But so your HTTP2 is largely broken or fixed at the point that the browser connection is terminated. So that's either your CDN or your load balancer or your server, if you happen to have a server that's talking to the wild internet. It's wherever the connection from the browser is terminated. If you have a layer 4 load balancer, which is a TCP load balancer, it can be a combination of whatever's behind that and the TCP load balancer that are at play. And so when you're doing HTTP2 prioritization on the server itself is basically just a traffic cop. It has a whole bunch of data coming in from the back-end connection. So if you had, like, in this case, it's 6 different requests that are all bundled over the same HTTP2 connection, it makes those all in parallel at the back end, and in theory, it has a whole bunch of data available to pick from on all of those connections when it has outbound buffer available, and it picks, okay, what's the next highest priority thing I need to send, and it sends it out on the buffer, and it needs to pick from what it has available. This is, of course, assuming the server supports prioritization. Most do, technically, just not practically. And so where it goes wrong is TCP send buffers. This is the problem we had at Cloudflare in particular. When your ops teams were scaling your HTTP1 servers, the goals were to shove bits out as fast as humanly possible with as little CPU as possible. And in HTTP1's case, there was never any contention or other things going on. It was a serial stream. It never changed. If you had the bits, they needed to go out on the wire. And so what happens in HTTP2's case is the traffic cop never has anything to do. So out of the 6 requests that it makes on the back end, as soon as the first one comes back, the send buffer is available. It shoves the entire response into the outbound buffer. It's not necessarily gone to the client yet. And so what you end up with is an order of responses in your outbound buffer in whatever random order your backends happen to come back with the responses. And those could be out of cache on disk from slower backends. It's completely random. And the HTTP2 prioritization has nothing to do, because as each one comes in, it has outbound buffer available. So it builds this enormous outbound buffer. I think in our case, the outbound buffers were something like 5 megs, which is bigger than most websites. So you can deliver an entire website in an outbound buffer without ever prioritizing anything. The other thing that wasn't entirely expected, which was a little surprising when we fixed it, our server metrics, the send times, tanked. Because when we had large outbound buffers, the server thought it had sent everything almost immediately, and our response times looked really fast from the server's perspective. And once we lowered the outbound, the buffers to be more realistic, we actually got real response times to the clients. What that means as far as solving it on the server, there's a TCP option called TCP not sent low watt, which what it does is it models what the outbound connection is and how much the outbound connection can actually sustain as far as data. And it says, okay, let's keep another 10K or 15K of data above and beyond what the network actually needs for retransmits. And it can dynamically adjust that. And so you can end up in a situation where your send buffers can still adjust dynamically, but they're only as big as they actually need to be to fill the pipe. And so all of a sudden now the server can actually prioritize correctly. Buffer bloat. You know, I heard a whole lot of stink about this like 5 years ago when cable modems were a thing. I was like, doesn't matter. Turns out buffer bloat's a huge problem for HTTP2. And so what buffer bloat is network devices over time have gotten much bigger buffers, memory. And so usually this matters most at your last mile connection. So in my case, I have a fiber connection, but like if you have a cable connection and your cable connection for your last mile is 5 megabit or 10 megabit, and their uplink is gigabit, you deliver a whole bunch of traffic over one connection to that cable front end, and it can only send 5 megabits or 10 megabits of traffic on the last mile. It doesn't just drop any packets that are faster than that. It buffers them up for a little bit so it can keep a stream of data going out. And those buffers growing end up being effectively the same thing as the TCP buffers. The network can now absorb megabytes of data. And so that was the other problem is even if you fix the TCP buffers on the server, you need to make sure you're accounting for buffer bloat on the outbound. Otherwise, the network absorbs all of the data in the responses and there's nothing left to prioritize. Where this comes You've probably seen the sawtooth pattern congestion control before. Probably not spent a whole lot of attention paying to what it really means. But what the sawtooth really is adjusting for how much data the network can absorb, and the buffer bloat in particular. And so loss-based congestion controls, this is Reno, QUIC, sort of the old classic congestion control algorithms. What they do is they throw as much data as they can at the network over time until it looks like the network lost data. So until it looked like all of the buffers filled up and stuff started to disappear. And then it goes, oh crap, I sent too much, drops down, and it grows, and it keeps doing that over and over again. But the key point is right at the beginning is it tries and fills up the network as much as possible until the data starts disappearing. And that plays right into buffer bloat's sort of key hand, right? Is like, okay, let's see if we can fill all of the buffers. And you really don't want to do that because you end up sending all of your data without being able to prioritize it. Newer congestion control algorithms, BBR is one of them. It's the most popular one. There are other flavors of it. What it does is it keeps increasing the amount of data it sends until it notices that it's taking slightly longer for the data to arrive to the client. And then it goes, oh, you know, there's probably something in the middle buffering somewhere. I've reached my saturation limit. Let me stop sending things. The bonus there is it also doesn't have to lose data and retransmit and all of that. It just goes, oh, okay, I think we've reached the limit of the actual transmit speed, keeping the buffers as low as possible. And every now and then it probes just to see if your connections have changed. And it tries to hug things as close to the optimal throughput as possible. But for what we care about here in particular is the buffers. It really minimizes the amount of over-buffering in the network. And so the combination of TCP not sent low watt on the server and BBR congestion control need to work together to minimize the send side of buffering for HTTP2 to even have a chance of prioritization working. The other thing you need to worry about is, in the case of multiple connections, the Thunderdome problem. BBR as a protocol is sort of known for being able to starve out QUIC and other congestion control. So if you have third-party data and your origin party data coming in over two separate connections, one of those is BBR, one of those is not, odds are the BBR one is going to use all of your pipe and starve out your other connection. And so if you're in an unfortunate situation where your images are coming over a connection that's BBR and your JavaScript is coming over like a QUIC connection, for example, they lost Thunderdome. And so your experience is going to be really bad. Outbound buffers are not the only place where you have problems. This is a big problem in Nginx, for example. When the server, the traffic cop, is negotiating or managing the upstream data that's coming in, you need to make sure you have enough data to pick from to be able to prioritize. And you get into a situation, if your buffers aren't big enough on the receive side from upstream, that you might pick like 5K of data from your high priority resource before you don't have any more data in the buffer, and you go to lower priority resources. And so you can also screw up your prioritization if you just don't buffer enough of the data available. And if you have upstream concurrency limits, can you handle the 100+ requests that the browser sent you all at the same time? Do you make all of those back-end requests, or are you only round-robining 5 or 6 of them at a time, at which point you can't prioritize again either? As far as the HTTP2 implementations on the server go, H2O is awesome. Kazuo has done an incredible job with that. It's basically the gold standard for HTTP2 implementations. Apache is also really good. Nginx, there are issues. It's got all sorts of buffering issues that still need to be sorted out to actually be able to prioritize correctly, even if you've got the network stuff configured correctly. So as far as a site developer, what can you do? The easy answer is use one of the CDNs on the good list, right? And then you just sort of forget about it. It doesn't matter what's sort of behind that. The real critical part is between the edge and the browser. Or you do need to worry about your networking stack, or at least have your ops team worried about your networking stack, congestion control algorithm, what web servers are being used. I pity you if you're using like an appliance, a NetScaler or something like that. The odds of those getting fixed or even support for prioritization are low to none. Probably just leave this in the slides for you later. These are the actual Linux configs for turning on a lot of those things. Prioritization, like I said, the browser requests prioritization, and sort of it's up to the server to do whatever the browser asked for. The browser doesn't, or the server doesn't actually have to care about what the browser asked for. So you can do things if you know better than the browser, like Edge, for example, about what you can do for prioritization. You're welcome to send back resources in whatever order you want. So that's one of the things we worked on at Cloudflare as well, where images we can do concurrently, even though Chrome asks for them serially, for example. And so maybe your application there, you know what your hero images are before the browser knows they're in the viewport, and you can prioritize those higher, for example. Wouldn't be complete without talking about HTTP 3 and QUIC. All our problems are over, right? Unfortunately not. It moves a lot of what we talked about with BBR and QUIC and sort of all of the congestion control and prioritization into the application layer. So it's no longer in the networking stack of the OS, it's UDP based. So now you're a lot more responsible in Nginx and Apache for doing not just prioritization, but all of the congestion control and buffering. The other thing to be aware of is HTTP 3 and QUIC will never, ever reach 100% availability because it's UDP based, because the enterprises can't man in the middle it. The easiest thing to do in an enterprise environment, for example, is to just block 443 UDP and force browsers back to HTTP 2, which they can man in the middle for all of their traffic logging and everything else. And if you weren't aware, by the way, all of your companies log all of your traffic. And prioritization in HTTP 3 was originally going to look a lot like the HTTP 2 tree. We managed to get it before the spec rolled out, and it looks like we're moving towards a much simpler model where there's like 5 priority levels by number and a separate bit that says download these resources concurrently or not. And so hopefully with that simpler model, we'll get all of the browsers behaving more like each other and much better server implementations. And so if you have opinions on what to do there, join the working group. The main takeaway I want everyone to try and get out of this is not necessarily to know about the networking stack details, but when you see weird shit in your waterfalls, ask why. Don't necessarily hack around it. Don't try and find a way to make it work. Dig into the details, because when you dig into the details, the really interesting stuff comes up. I mean, you get scared to death about how broken the internet is, but you can fix a lot of stuff, and you can fix sort of your long tail and the core root problem instead of sort of working around it for your one case. Thank you. Wouldn't be...
That was awesome. Go ahead, have a minute for...
Darn, I didn't use up all my time.
We're going to make you answer a question, at least. So yeah, we've probably only got time for like one question, so let's see if it's...
I'll happy to talk to people in the hallways too, though.
Awesome. Yeah, 'cause somebody made the observation, like maybe HTTP 1 wasn't so bad. Can we turn back time?
I mean, it's scary, but that's what Chrome did, right?
Yeah.
For everyone by default, basically, is if it detects a slow enough connection, it resorts to the HTTP 1 prioritization because things are just so broken in the wild.
Well, there you go. Thanks, Chrome. I was personally gonna ask you a question that we can save for later on, which is like, what's your dream browser? So we can talk about that later on.
I mean, Chrome does almost everything perfectly. I just want the images to be concurrent.
I'm just more thinking like if you could design one from the ground up, but that's a bigger question. What's Pat's dream browser? I want to say that's the one I want to use. Okay, so one question, and let's ask this one. So, what's the best way to test HTTP 2? It is hard to say. Push. Simply avoid browser throttling and use system throttling.
To test push, a packet shaper, network link conditioner, wind shaper, but more importantly, just don't use HTTP push. It is broken. There is like no site ever that has been able to figure out how to get push to work in a net positive way universally. I think Akamai has like found one edge case where they can sort of, if they know how long it takes the server to respond, and they know the available bandwidth and how much data they can send to the user before the server is going to respond, they can maybe push those resources without impacting the overall. But in most cases, the cases where, especially if you're using like link rel preload in your headers, and your CDN automatically translates those into push, you're shooting yourself in the foot. I'm surprised we haven't been able to kill push yet. It sounded really exciting. It was sort of worked into the spec as the last minute of, wow, this would be awesome, let's do this as well, without sort of the proof that it works like we needed with Speedy and everything else. But if you are using push and you're experimenting with push, just stop. Preload works much better. It's friendly to the browser and sort of the browser model, and it's less likely to make things worse.
I like that you're just full of like declarative opinions today, like no web fonts, progressive JPEGs, don't do push.
And now you know what my perfect browser would be, right?
Yeah, there you go.
It doesn't support web fonts, it doesn't support push. And I'm on MySpace, right?
Awesome. Okay, well, thanks very much, Pat.
All right,
And he'll be around during the breaks if anybody has more questions. Okay.